The following is the first of two videotapes featuring Seymour Papert on Logowriter. How to use it and how to think about it. In demonstrating Logowriter, Papert uses the occasion to deepen the viewer's understanding of logo itself.
Well, that's one sort of Logowriter graphics. Much less hard-edged, you'll notice, than what you usually see on logo screens, though not at all less interesting and rich mathematically. It's also easy. You should be able to do that sort of thing in your first half hour of contact with Logowriter. In a moment, I'm going to show you something somewhat more difficult. A Logowriter project that's a composite of work by several teams of highly motivated fifth grade students. I think it really represents the level of achievement that a teacher who already knows logo should be able to attain after several days of immersion with Logowriter. This project will be the first of 4 chapters in this module. In it, I don't have a specific teaching goal. My goal is to help you set your goals rather than to get you techniques or specific ideas. I'd like you to see what you're working towards. The second chapter will have a very specific teaching goal. I'd like to get you to that level in Logowriter where you can do what you're used to doing with ordinary logo. My emphasis will be on getting you used to a new approach to writing procedures, to editing, to saving your work, to getting it back, to the whole area of interface management in logo. It's the third and fourth chapter that will bring us to doing things which really look different from what you're used to being able to do. We'll be doing projects that are almost impossible in traditional logos. Before we get started, let me say something about computers. In the module, we'll be working with Apple and IBM. As you know, Logowriter sets out to have a new level of compatibility across computers. Most of what we'll do will be the same and look very similar on the 2 computers. When occasionally the keyboards dictate differences, we might mention them specifically. So let's get going. Let's boot up our Logowriter and see what it looks like on the screen. When we obediently press Enter, we'll see a screen that shows us the first of the major differences between Logowriter and traditional logo. The word contents refers to a metaphor used by Logowriter to represent the material from previous work stored on the diskette. We select an item by moving the cursor down with an arrow key. I'm selecting Scale. I press Return, and you'll see in a moment on the screen the graphics and some text, and in a place that I'll show you later, the procedures that drew them just as they were left, saved automatically by Logowriter. Looking at that graphics, you see a second major difference. Look at the fine detail of the graphics. The skeleton was actually drawn by a team of 4 fifth grade students working together. I think with traditional logos, they might have been able to draw it, but I doubt if they would have. Finally, the combination of text and graphics here shows us the third of the major differences I shall be talking about: Logowriter's ability to deal with text, which is why it's called Logowriter. I'm going to clear the screen and show you the procedures that put up this text and graphics. Start is the name of a procedure that clears the screen and positions the turtle to draw the skeleton. Scale is the procedure that does the actual work. There comes the skeleton. We'll see later how that's done. And finally, when the cursor blinks again, the procedure What puts up the text. Now, when we look more closely at this text, we'll see the third aspect of Logowriter in greater depth. This text is not just dead text written on a screen. It's living text, interactive text. And to show what I mean, I'm going to move this cursor, the active blinking cursor, up onto the text part of the screen by doing the up key. Once it's there, I can move it around using the up arrow and then the right arrow, positioning it there, and you've guessed why, because I want to correct the spelling mistake. I type an E and it's corrected. In other words, we have here not merely dead text on the screen, but all the power of a word processor. We can manipulate this text in many different ways. And let me show you one special one. I'm going to move the cursor down onto skull. I select skull. You'll learn in a while what that means exactly. It being in red shows that it's selected. And now when I obey this instruction, doing Control X, the skull turned blue, showing which bone of the body was called the skull. I could have selected hand, clavicle, shin, or any other. Let's see what happens when we press Control V. Control V is going to get us into a database in which the young programmer has written some more text that tells us about the skull. The skull, he said, has several bones. It protects the brain. Surprisingly, Hamlet once recognized one, and so on. But of course, this could have been biological knowledge. It could have been a description of the bones and how they fit together. It could have been advice about how to draw. For me, the Skeleton project hints at a new integration of computers into learning. First, there's integration of computer methods. Programming, text manipulation, database manipulation are inextricably mixed together. You can't say it's one or the other. There's also, because of this integration of the computer methods, a tighter kind of contribution to learning the biological knowledge and to learning something just as important, the art of collaboration. I'm sure you're eager to see what you'll learn by doing such projects. But I think that the best entry point is to begin by looking again at what you already know very well, at what you're most familiar with. Let's take a look once more at the familiar turtle. Here's our turtle, and here's a familiar instruction. Press Enter, and it draws a line. Write 144, which you know if we repeat will produce a star. It's turned. And now, to continue the star, we could do forward again, but instead of that, in this version, I can do something very different. Watch the cursor. I put it back on forward, and you'll see another way in which text remains active in this version, because when I hit Enter, it'll do forward 100 again. Now it's on right 144, hit Enter, and it's turned. Arrow key takes it up, and so I can draw the whole star without any more typing except hitting the arrow keys and the Enter key. The text of the instructions that have already been run are kept active. Let's go back and see in more detail. I put it up once, I put it up twice on forward, I put it up on pen down. What will happen if I try again to put it up? It'll bump against the red line. Oh, but you see there's more there. These were the instructions that I used to set up the turtle for this demonstration. Clear graphics clears it all away. Set color 9 made the color blue. Pen up. Set pause, put it in the right place. Pen down, forward 100, right. And so we see how the instructions remain active in what we call the instruction buffer. This might seem like a very small example, but it's a big example to get us thinking about what goes on when we work with Logo. You may be surprised I'm fussing so much about being able to reactivate an old instruction. After all, retyping forward 100 isn't all that much work. But you'll see that Logowriter's way of keeping text active is not only very, very useful, beyond being useful, it leads us to more coherent and I think much more concrete ways of thinking about what we've always been doing when we do Logo. To make this point, I've prepared some simple props that any teacher could make, and I recommend that teachers do make them. For example, this one represents the Logowriter screen. There's the red line that should be familiar by now. Up here is a star the turtle has drawn. This part above the red line is called the page. It's where the turtle works. It's where text appears. We saw the skeleton over there. Below the red line is called the command center. This is where we put commands. Here it's as if a procedure had been written. Star and run. And that made the turtle draw this. Have you ever puzzled about where these procedures are that make the turtle draw things? And have you puzzled about where children think they are? Sometimes we say they're in the workspace or in the computer's memory. But these are very abstract ways of talking. And similarly, have you ever puzzled about what happens to old instructions that have been used and spent? We say the computer has forgotten them, but there they are, often still on the screen. Again, there's something abstract about the computer having forgotten what's there visibly on its screen. I think we need much more concrete ways to think about all these issues. And Logowriter has been designed to provide some. Logowriter has a consistent metaphor for where the procedures are. Here's the page, here's the turtle's work. Flip the page over, there's the procedure on the flip side of the page. This metaphor is carried out consistently right through Logowriter. There's a key called the flip key. If you're on the flip side, press the flip key, you get on the front side of the page. If you're on the front side, press the flip key, and you get on the flip side. On the flip side, you always find all the procedures that can be used at any given time. If you want to change them, you can use your word processor. When you write a procedure in the first place, you turn to the flip side and you type it in. The procedure is just a piece of text, like any other text. Now, what about direct commands? Let's get rid of this and get this prop. Forward 100, right 144. That should be familiar. Here's the cursor that we were moving up when we drew the star by direct commands. When the cursor got to the top, what happened? Well, the analogy is with a scroll of ancient times. As we turn the roller, the next instruction comes down. They're all there. We're looking at them through a window. The command center, then, is a window through which we look at a place, the instruction buffer, where text can be written. And what's written here is, again, text that can be processed, edited, changed, just like the text on the flip side of the page, just like anything you might write on the front side of the page. It is this concept of text that gives Logowriter a special degree of coherence that no other logo has ever had. We saw how to draw a star by direct instructions. Now, with these images of buffers and pages in mind, let's see how to do it by writing a procedure. We're back at the contents page, and I'm going to put the cursor on new page because we want a brand new page. There it is, no name, just the question marks, and the first thing we have to do is give it a name. Why not call it star? Name page star, and you should see the word star appear at the top. We now have the page star. We don't do anything on it, we flip it. You see we're now on the flip side of the page star. But to make that more concrete, maybe we should leave the screen and see what it looks like on some keyboards. On the IBM keyboard, the flip stroke is Control F. Press Control, press F, release Control. That gets the flip side, that gets the front side. On the Apple keyboard, the flip stroke is Open Apple F. That brought it to the flip side, that brings it to the front side, that brings it back to the flip side. Back on the screen, we're on the flip side of the page star, ready to define our procedure. I'm going to call it to pentagon and leave it to you to decide whether it really is one. In traditional Logo, I would start writing repeat there, but in Logowriter, I can do something more interesting called formatting. Repeat like that, and then let's put the first input over there, and then let's put the next input underneath it. You don't have to do this. You can lay it out any way you like. Logowriter allows you to use any formatting you like that happens to make it readable for you. I think this is very readable. To pentagon, separated from the body of the procedure. Repeat has its two inputs, indented a little back and underneath one another. End. Let's flip back and see if it works. Here we write the instruction pentagon, and it should draw one. There it did. There's the pentagon, there's the flip side, there's the front side. And now let's look at the contents page, which we get by pressing Escape. The disk is whirring. It's back to contents, and look there. On our contents page is star. And if we go down and select star, we find it exactly as we left it. Our pentagon, of course, the buffer for instructions is still there, and if we flip it, there's our procedure. Escape will take us back to contents. And there's our star, added to the other pieces of work that we've accumulated.